Hello, Kim121. Good morning, good afternoon, good evening, grand risings, wherever you are and whatever time of day you're listening to this. Good day. So check this out. I've received a lot of emails and text messages in reference to me doing a separate video on the scientific notation. And so I'm going to do that one here, but I'm trying to keep it a little short, but y'all know when a teacher says they're going to keep things short, you know that it's going to be a little lengthy. So I'm going to try to keep this video under 10 minutes so you can digest the information in small chunks. So if you like this video, let me know. If you have comments about the video, put your comments in the comment box and I will try to get back to you. In the meantime, let's go ahead and get into it. All right, so on the screen, you've got a problem that's dealing with scientific notation. Now, there are several ways you can approach scientific notation, and I'm going to elaborate further. Here's the thing. When you have a large number, such as what you see on the screen, large numbers are things like this, for instance, 157,000, okay, versus 0.157000. Anytime you have a decimal at the very beginning of the number, followed by, a zero with a decimal, followed by other numbers, this number, of course, is way smaller than the number over here on this side. So I'm going to show you all some tips and tricks that can help you get through this knowledge. Let's go ahead. All right, so here's some of the things that you all need to remember as you are trying to take a number from scientific notation into what we call, anytime you're trying to take a number from standard form or decimal form to scientific notation, you must simply move your decimal until you get between the first two significant digits. In other words, if I take the number like 157,000, I'm going to assume that the decimal is at the very end, although I don't see it there. Now, before you go any further, take a look to see how many sig figs you have. Remember, if you do not see a decimal in your original number and there are zeros, you only consider the 1, the 5, and the 7. So in this case, you have 3 significant digits or 3 significant figures. So I'm going to assume that the decimal is at the very end and I'm going to move it back. 1, 2, 3, 4, 5. So it took me 5 steps to get there. So that's going to be my exponent. And I'm going to write 1.57 times 10 to the 5th power. Now, you'll notice on this worksheet, they included those zeros. However, they made some errors because if you go through the rest of the worksheet, you'll see where they left the zeros off on some of the other practice problems. So, FYI, that's a little small notation to kind of recognize, but don't get too caught up in the error of that one part. And that's why I wanted to kind of explain that to you, because when you look at the answer key in the very back, you will notice, hey, they don't include all the zeros when there aren't any decimals involved, okay? So let's do another one just to make sure we're clear on what I just indicated, okay? So let me go ahead and erase the screen, okay? So that way you all can see a clear and concise example. And we got some other examples we're going to do, but I want to make sure I clear some things up for you. All right, so let me give you another one. Let's say that I have 2,437. And I said put that in scientific notation. You're going to assume that the decimal is at the very end of your number, even though you don't see it. Move your decimal back until you get to between the first 2 significant digits. That's 1, 2, and 3. So because it took me 3 steps to get there, that's going to be my exponent. And yes, you will write all those numbers down. 2.437. That is your answer. Now, you're probably wondering, what if I have a small number like this one down here? What do I do? Well, you're going to move your decimal to the right this time. So what you notice is that when you have large numbers, okay, you will move your decimal to the left, okay? And your exponent will be positive. So that's something you need to think about whenever you're having these problems. So again, in the first set of numbers that we did, the first couple of examples, because this was a large number, we moved our decimal to the left and the exponent was positive, okay? And you wrote the entire number out. Now, when you have a small number, your exponent will be negative. So let me show you what I mean by that. Okay, so right here, you've got 0.000837. Now, remember, you're going to move your decimal between the first two numbers here. So let's see how many steps it takes. 1, 2, 3, and 4, right there. 8.37 times 10 to the negative fourth power. Because it took us 4 steps to get there, I wrote times 10 to the negative 4. Now, here's another little trick that you all can think about. Count the number of zeros you see. 1, 2, 3, 4. Guess what? That also equals your exponent. I'm going to do another one just so you can see how easy this can be. 0. Let's say 0.0000892. Okay, let's go ahead and count those zeros and we can see how easy this is. We've got 1, 2, 3, 4, 5, 6, 7. Guess what? That's going to be my exponent, but to the negative power. And then I'm going to write 8.92. See how simple that is? Now, in case you're wondering, okay, I want to go back the other way. I want to make sure I'm able to do this, okay? Let me show you how simple that can be. And my screen just went down. Sorry. All right, here we go. All right, so if I take that same number again, okay, 0.1234, okay? And I move my decimal, okay? Watch this. 1, 2, 3, 4, 5, 6, 7. It took me 7 times to move it. And because this was a small number, it's to the negative power. 8.92 times 10 to the minus 7th power. Real simple. Now, let me give you the notes that you'll want to make in reference to that part. Move your decimal to the right. The exponent will be negative. Okay? Move your decimal to the right, your exponent will be negative. Now, we've got these two examples right here that we're going to do, A and B. Okay? So let's go ahead and look at that. So we've got 530,000 liters. Okay, you're probably wondering, all right, that looks like a very large number. You're right. It is large, so guess what we're going to do? We're going to make sure that our exponent is positive. All right, so let's do this one. All right, here we go, ladies and gentlemen. We've got the decimal on the very end. Assume that it's on the very end. 1, 2, 3, 4, 5. So because it took us 5 steps to get there, my exponent is going to be to the 5th power, and it's going to be positive. And because I have two significant digits in my number, I'm only going to write 5.3. You do not write 5.30000. You're only going to write 5.3. Now, if this would have been 530,000 with a decimal on the very end, then you would have written out 5.30000 times 10 to the fifth power, okay? Because in this case, you would end up with 6 significant digits, and you would need to write them all out. 1, 2, 3, 4, 5, 6. So you would have 6 numbers. But in this particular example above, we only had 2 significant digits. So that's why we did not want to include the other zeros. Now let's look at the next example. We've got 0.00053. Let's count the zeros. We've got 1, 2, 3, and 4. So guess what our exponent is going to say? Times 10 to the negative fourth power. Because remember, this is a very small number. When you have zeros in the front, 0 point, how many ever zeros you have, okay, you're going to make sure that you put that as your exponent. And then you write the other numbers, 5.3. Okay? See how simple that is? So let's go ahead and do some more examples to make sure we're okay. All right. So in the next example, you've got 0.0000092. Let's count the zeros to make sure we have the right exponent. We have 7 zeros. So our exponent is going to be negative. So we're going to just simply write 9.2 because we only have 2 significant digits, the 9 and the 2. 9.2 times 10 to the negative 7th power. Now you're probably wondering, okay, but what if I want to do it the other way by moving my decimal? Well, you can do that too. Watch this. 1, 2, 3, 4, 5, 6, and 7. Right between the 9 and the 2. You do not want to put it at the end of the 2. You do not want to put it before the 9. You want to place the decimal between the first 2 significant digits, the 9 and the 2. Letter D. Assume the decimal is at the very end. Although you don't see one, I'm just going to go ahead and write 6 times 10. Because guess what? There aren't any decimals here, so I don't have to put that in my number, and I don't have to put all those zeros. But I do need to count back. And because I'm moving my decimal to the left, my exponent is going to be positive. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you're just going to write the units out. All right, let's look at the next example. You've got 12 million, no, that's 12,600,000,000 milligrams. That's a large number. So we're going to go ahead and start at the very end, assume that the decimal is there, and move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're going to write only the 1.26. You don't need to include those zeros. Times 10 to the 10th power milligrams. So if you're probably wondering, okay, Bishop, I think I understand what's going on. Let's see. Okay, so I wanted to show you all the answer key so you could see that here. And if you look in the first couple of sections, let's see if I can zoom in so you all can see it here. Okay, and you can see how they did not include the zeros in the first example that I gave you. All right, and then if you look at the other examples, you can see that here. And let's do a comparison. All right, now in this next example, they're going to ask you to rewrite the following in decimal form. So now what we just did at the very beginning of this video, we went from scientific notation to decimal form. And some people will say standard form. It means the same thing, okay? So decimal form is the same thing as standard form, okay? So depending on, what book you read it out of. So what we're going to do now is we're going to go from scientific notation to decimal form. So we're going to actually work backwards. So we're going to take a scientific notation number and put it in decimal format. So let me go ahead and erase the screen so we can start clear with a fresh palette. All right, here we go. So in this example, you have to take that 1.87 times 10 to the negative fifth power and put it in decimal form. How do you do that? Let me show you. Because your exponent says times 10 to the negative fifth power, that means I'm going to have 5 zeros. 0, 0, 0, 0, 0. That's 5 zeros. And then 187. Guess what I'm going to do? I'm going to put my decimal right in between those first two significant digits. Now, in case you're wondering, okay, Miss Ship, I see that, but what if I wanted to do it a different way, where I'm going to move my decimal to make sure? Okay, you can do that. As a matter of fact, I'm going to put the number here, 1.87, the base. We call that the base, okay? Whenever you're dealing with scientific notation. You're going to take that number, that decimal rather, and you're going to move it back 5 places to the left. So remember, ladies and gentlemen, when you have a negative exponent that you're trying to put in decimal form, if you have to go to the left, okay, when you're moving your decimal to the left, your exponent is negative. So it's kind of like the opposite of what we discussed earlier, okay? So I'm going to go back 5 places to the left. In order to get a small number, you have to go back to the left. So that's 1, 2, 3, 4, and 5 right here, okay? So you're going to fill in those lumps with zeros. 1, 2, 3, 4. Now you're probably saying, wait, Professor Ship, I thought I saw 5 zeros. You're right. At the very beginning, you're going to include that 0. So you would say 0.0000187. Okay? Letter B. Because you have a positive exponent, you're going to move your decimal to the right. Because you have a positive exponent, you're going to move your decimal to the right. Okay? So here we go. You've got 5.99 times 10 to the 7th power. So that means I'm going to move my decimal 7 times to the right. All right, so here we go. 1, 2, 3, 4, 5, 6, 7. Right there. Now, you're probably saying, so should I go ahead and put the decimal at the very end? No. Here's the reason. Your original number had 3 significant digits. Therefore, your final number should still have 3 significant digits. So what you're going to do is write in those zeros in those little lumps right there. And that's it. Although your decimal stopped there, you do not want to include the decimal on the very end, or you're going to end up having a higher number of significant digits. So I'm going to go ahead and put those other zeros in my number. 1, 2, 3, 4, and 5. Okay, I keep forgetting my units, but you all do not want to forget your units. Okay, so if you want to check to make sure you did this correctly, simply move your decimal back, okay? So that way you can see what you're doing. 1, 2, 3, 4, 5, 6, 7. And that tells you that you did it right. Let's do another one to make sure. 9.001 times 10 to the 3rd power. Remember, our exponent is positive, so we're going to move our decimal to the right 3 times. 1, 2, and 3. So we end up with 9001 milligrams. And if you want to check to make sure you did it correct, guess what you do? move your decimal. 1, 2, 3. So you moved it back, and that shows you that you're on the right track. All right, I'm going to let you try letter D and letter E. Pause the video, and I'm going to put the answers on the screen, and you can check yourself to see if you're on the right track. All right, let's keep going. Suppose you have some calculations here, and I told you to take the number that's in decimal form and put the answer, the answer is in scientific notation, put it in scientific notation. Okay, how would you do that? Well, you can use your handy dandy calculator, okay? A little throwback to Blue's Clues. You know, some of you all may remember Blue's Clues, and he always loved his handy dandy calculator. But anyway, if you have 2.3 times 10 to the third power plus 3.5 times 10 to the third power, what do you do if you don't have a calculator? All right, let me show you. You can take this number here and put it in decimal form. And if you remember what we said, when the exponent is positive, you're going to move your decimal that number of places to the right. So let's go ahead and do it at the very top. 2.3 times 10 to the third. I'm going to move my decimal 3 places to the right. 1, 2, and 3. Fill in with those lumps and you get 2,300. We do not put the decimal on the end because we only have 2 significant digits, so we're going to keep our 2 significant digits. 3.5 times 10 to the third, well, that number is the same. It's going to be 3,500. Why? Because I'm going to move my decimal 1, 2, and 3 places to the right, just like the other one before. So when we add those two numbers together, we get 5,800 grams. But if I told you put that answer in scientific notation, all you have to do, ladies and gentlemen, is move your decimal back 1, 2, and 3 places to the left, and you end up with that as your answer. Okay, so you've got several more examples, and I will put the answer key up on the screen. So I'm going to pause the video and let you all do these others, B, C, D, E, and F. Pause the video. Well, let me go back for a minute. I'm going to do letter E because those are negatives. But I want you to pause the video and do B, C, and D, and I'm going to do letter E. B, C, and D, the answer key will appear on the screen. Let me go ahead and do letter E, though, while we're doing this together. We've got 4.72 times 10 to the negative fifth power plus 4.66 times 10 to the negative fifth power. All right, remember what we said. You can either move the decimal back or just simply write down 5 zeros. And 472, okay? 4.66 times 10 to the negative fifth power. Write your 5 zeros. 466. And put a decimal between the first two. And go ahead and add those numbers together. Again, for those of you that do have calculators, this is simple to do. But if you don't have a calculator or you're just practicing, you can do it this way as well. So I'm going to add those up. And I get 0.0000938 milligrams. But if I want my answer in scientific notation, remember you're going to count those zeros, which is 5 of them, and that's going to be my exponent. 9.38 times 10 to the negative fifth power milligrams. All right. Let's do one in which you have to multiply and divide. I need to go back and say something about that though. When you are adding and subtracting, you must do the least amount of significant digits after the number. And if you notice after the decimal, if you notice all of these examples here, they had the same number of significant digits. That's why these were rather easy in terms of being after the decimal. If I look at this number here and that number there, they both have two significant digits after the decimal. So that's why your answers will be with the least amount after the decimal. This number has one significant digit after the decimal. This one has one. So when you add them, your number will have one significant digit after the decimal. But now the rule changes when you are multiplying and dividing. So let me show you what we mean by that. Okay, so if you are multiplying or dividing, you're going to look at the entire number and round off to the least of those digits. Well, in these particular examples, that's going to be quite easy because when you talk about the least amount, both of them have the same set of numbers, same set of values. So the number still stays the same. So let's go ahead and do letter A, okay? So that we can see how we would work these problems. All right, so letter A. You've got 4.7 times 10 to the fourth power kilometers times 1.1 times 10 to the second kilometers. All right, so here's what they want you to do. You're going to take that number. If you want to take it and put it in standard form, decimal form, that's fine. Remember, 4.7 times 10 to the fourth would become 47,000. And how do we get that? Because remember, 4.7, you move your decimal 4 places to the right. Because it is positive, you're going to go to the right. 1, 2, 3, 4. And fill in those lumps with those zeros, and you get 47,000 kilometers. You're going to multiply that times 1.1 times 10 to the second power. So you're going to move your decimal 1, 2, 2 places to the right. So that's times 110 kilometers. Well, we can go ahead and get our calculator, plug those numbers in, and let's see what we get. So when I plug it in, I get 5,170,000. But remember, we're going to put this answer in scientific notation. So you can assume that the number, that the decimal is at the very end. So I'm just going to go ahead and move it. 1, 2, 3, 4, 5, 6. So I would get 5 point. Now, let's talk about this for a moment. Because we are doing our answers based on the least amount of digits, that means I need only 2 of those numbers. So although you have 5.17 times 10 to the, let me go back and recount, 1, 2, 3, 4, 5, 6, to the 6th power, if you wrote that as your answer, that would be wrong. You need to make sure that you have the least amount of digits in your entire number. So you would have to round off. So that means if I look at 5.17, okay, and if I shade in just the first 2 significant digits, that 7 tells that 1 raise up. So you have to raise the 1 to a 2, and you end up with 5.2 times 10 to the 6th power. And that's kilometer squared. Okay? And if you're saying, oh, I think I need another problem, let's do one more. Let's do letter C. You've got 4.5 times 10 to the third power. Again, because that's to the positive third power, I'm going to move my decimal 3 places to the right. 1, 2, and 3. Fill them in with zeros. So you end up with 4,500 with the big M, okay, molarity, times 1.5 times 10 to the negative second power. Remember what I told you? You can easily take to count the zeros and then write your number out. Okay? Or move your decimal 2 places to the left. And so you end up with 0.015. Same thing. Now remember, when you multiply those two numbers, you need to round it off to make sure that you have two significant digits, significant figures in your number. So here we go, 4,500 times 0.015, and I get 67.5. But remember, we don't want all of those numbers. We need to round up. So therefore, if I just highlight only those first two numbers right here, the 5 tells the 7 to go up. You're going to round off that 7 to an 8. So you end up with 68, the big M squared. Okay? I'll leave the answer key up so you can do letter B and letter D. This same rule applies if you were dividing. So that's it. I hope these answered your questions when it comes to scientific notation and how to do them. They are not difficult at all, but if you just remember the rules, you should be good to go. All right, guys, if you have questions, put them in at the very bottom of the screen, or you can always email me. Have a great one.